Hello.
All right. Oh, we have 1 minute left. Why don't we start?
Okay. Hi, I'm Dick Wall. This is Bill Venners. We together are Escalate Software. We do training and consulting in Scala, and what we're going to do today is kind of an adaptation of the first day of our training course that we normally do. It's the first time we've done it in this kind of format with a lot of people, and we won't be doing the the interactive or the hands-on exercises that we normally do in between each module. So it's going to be a bit different from normal. I think questions are going to be interesting. Maybe we'll have a set-aside question time if you take a note about a question you've got, because there's a lot of people here. So it's not like just one of our classes where people just sort of ask questions as we go. And we'll just kind of go through and get as far as we can in the time we've got allotted. This afternoon we're doing a hands-on lab. I don't know which room it's in offhand, but you guys probably do by this stage. But we're doing something called the Scala Coins, which is an open source project, and I'll have some information on getting set up for that before we finish this morning's one. And then tomorrow morning, I think it is, we're doing another presentation, another university session, and that's advanced Scala, and it's for people who have been using Scala already. It's talking about idioms, patterns, library design, stuff like that. It's not intended to be a follow-on to this one. If you're coming here because you've not used Scala before, tomorrow could be bewildering. Just warn you.
Well, they have all afternoon to...
Yeah, to get like experts on Scala, yeah.
Yeah.
That's all it takes really, is an afternoon. But yeah, tomorrow is for people wanting to sort of see best practices and stuff. Some of it may be a little scary if you haven't been into the Scala type system and stuff like that. So just warn you ahead of time. But today doesn't assume you know anything about Scala yet. And we're going to move through kind of the basics of the language. The course normally covers things like the libraries, stuff like that. But what we're mostly going to look at today is the language, the REPL, control structures, function literals and closures. I think writing your own control abstractions if we get there. At the end. Okay, before I start, who's jet-lagged? Anyone? Yeah, I see a couple of hands. I am, so we'll see how that goes. That could add a new wacky dimension to the whole thing. If I start saying weird stuff, that's why. Okay, so let's kick it off. We've got slides up. Let's see. Actually, I should probably move to where I can see your screen, so I can remind myself what's on the slides. Scala interpreter, or the REPL as it's known, the read, evaluate, print, and loop, is something that I've been using Scala for probably 3 or 4 years now, and I think Bill's the same. The REPL is something that you still use, or that we still use every single day. It's one of the big advantages to using Scala. You can actually get in and try stuff out, and it's useful even if you're a Java developer. You can import libraries and start using them and messing with them. And you get quite a lot of stuff. So Bill's got the REPL up here. You can,
yeah, just say Scala, and the current release version is 2.9.2, and
yeah.
There's a 2.10 is imminent. So I'm going to show some things with 2.10 and some things with 2.9. But normally what you would just say is Scala, and when you say Scala, you get a prompt like that.
So yes, you can start typing stuff now. So if you type in something, well, yeah, you can't really type stuff. Try typing something like 1 plus 2.
1 plus 2.
So it can add up. First thing, yay! Thank you, Carl. So there's a couple of things to really notice about this, though. First is that you actually get a type. So Scala's a strongly typed language, like Java is. It feels, in this environment, it feels like a dynamically typed language because you're interacting with it. But everything is assigned a type, and it has type inference. So when you do 1 plus 2, both of those are integers. It knows the plus operation, and it knows that the result will be an integer. So you'll see that res1 comes back, and it says int3. The other thing worth noticing is if you don't specify a variable to assign this to, or a value to assign it to, it gives it a res. It counts up, so result 1, result 2, result 3. And that's pretty useful, because then you can refer to that in later work. So it's very nice. It just kind of stores everything in a memory and lets you use it. Okay, what's on the next slide? Defining variables. So actually, Not all variables are variable in Scala. One of the first things that you'll find as a difference from Java is that when you define something, you can either make it a val or a var. And a val is immutable. It's a constant. And that's a decision that you make right at the time that you define this thing. Whereas in Java, it's an extra step to make something final. In Scala, it's very much on an even footing. And in fact, you'll find that practitioners, Scala practitioners who have been doing this stuff a while, they'll tend to use vals a lot more. It does become something that leads to a lot more code reliability. So yeah, here's an example of
Yeah, every time you try to reassign a val, you'll get that funny noise.
Yeah, whatever that noise was,
and that'll warn you that there's a
warning sound. So a val, you can assign it, but you cannot reassign it. Now, there's a slight exception, though, in the REPL only, that you can redefine a val. So here, hello again, world. And this is not reassigning that val. It's actually creating a new val with the same name. And the way you can think of this is it's sort of like every time you start a new line in the REPL, you're getting a new scope, a new nested scope. So what's actually happening is outside of this current command line, you've got the old val message, but it's now been hidden by the inner scope. So that's just something that you can do in the REPL. You can also do that in any Scala program. If you've got a val message and you open up a new pair of curly braces, you're in a new scope. You can hide the one outside of it with one inside. So that's why it looks like we're kind of reassigning, but we're not. We're assigning, but we're not. We're actually defining a new message when we do that. Oh, and a couple of other things from this slide. One of them is that the types are optional. You can see at the top there the val message, hello world. It infers that it's a type string, but you can also choose if you want to specify that. And you can say it's a Java lang string, or you can say it's a message of type string. And all of those do exactly the same thing, but in one, you're letting Scala infer the types. In the other two, you're actually enforcing that type. Okay.
And the order is you put
right.
kind of opposite from Java. You put a colon and put the type afterwards.
Yeah, you put the name first and the type after, and that becomes very natural after a while. Okay, so what's next? Hello, there we go. Okay, vals and vars. So I mentioned that you've got the choice in Scala. A var is kind of what you're used to using from the Java side of things. If you specify something's a var, then you can reassign it. It's mutable. And it's basically, and this is kind of the philosophy of Scala, is Scala's not your keeper. It's not your nanny. Okay, it lets you do what you want to do. The fact that val and var are separated by just one letter and they're the same length, all of that stuff, it lets you choose which one you're going to use. It doesn't push you that much one way or the other. Now, good practice says that try and use vals whenever you can. Certainly, it's not any harder to use a val. It's the same amount of typing, unlike Java where you'd have to put final all over the place in parameters and stuff like that as well. And Scala has a few places where val is the norm. So parameters that passed into methods are vals, things like that. Things that you would naturally expect there to be a val. It's a val. Multi-lines, if you start an expression and you don't finish it, and Scala knows that this expression is not yet finished, it gives you a continuation line. So if you say val multi-line equals, and then the equals, obviously there's nothing on the right-hand side of that. It's an incomplete expression, so Scala gives you a continuation. If you get into a situation where, and you can quite often do this if you've got lots of parens or curly braces, you kind of lose track where you are in the thing, and it won't let you out of this. If you hit return twice, it just abandons the current statement that you're doing. It doesn't try and evaluate it or anything, it just comes out of that. So that's a way of getting out of that. Now this is probably one of the nicest features in the REPL, and this is super for people just messing around with new libraries and stuff like that. When you're in the REPL, if you've got a variable, or some kind of value, some kind of object, if you type that object name and hit dot and then you hit tab, it actually gives you code completion. it tells you what you can call on that. So you can see all of these methods are available on string. And if you start typing one, then it limits the items that you see when you hit tab to just those ones beginning with C or CO. And then you keep typing until it sort of, what have you got there? Probably contains, H. And that comes back as true, and it's a Boolean. So again, the type inference is kicking in for us. We don't have to say explicitly what these types are. It's all good. Right. Shell commands. So there's a number of kind of meta commands in the Scala REPL as well, things that you can do. And these all begin with a colon. So you can type things like
colon Q.
Colon Q. Yeah, that quits. You can do colon sh space ls, and that will actually spawn a process, and it will give you the results of an ls. If you do ls.value now, I think it is, or res0.value.
I'll hit tab. Let's see what we got.
I think it is
lines.
That's it. Lines. And hit. You can
just say.
You can just. Oh, you could do.
Just to show it.
Yeah.
Oh, it's empty. There's nothing in the current
directory.
Yeah.
Okay, but that would give you a list of files or file names. And what's nice about this is it actually brings it in as a Scala collection, so you can now do useful things with it. So have you opened it in a different directory?
No, I just created a file.
Okay.
So now when I do it, I should be able to see that a file.txt.
Yep.
There it is.
And that's now a Scala collection, so you can do operations on that. So if we do a res1.map.
It's one dot map. Two uppercase or something.
Yeah.
Okay.
And we're getting a little bit ahead of ourselves, but we'll get to that. But you can see you can actually do operations on this list that you've got back now, which is pretty handy. Okay.
So that's sh.
What else is there? There's help, which gives you a
good.
list of the shell commands that you can get. If you get really into this, we're not really going to cover it today, but there is a power setting. The power setting, if you turn it on, it gives you a whole bunch more shell commands, and some of those are really quite advanced. They're stuff that the core Scala team has put in there for all sorts of different reasons, and you can do things like evaluating the type of the resulting type of a expression without actually evaluating the expression and things like that. There's all these kind of things. You can stop the compiler at a certain point and get it to dump out the abstract syntax tree at that point. There's all these kind of really powerful things that you can do in the REPL if you need to. What else have we got? We've got
another
history.
good one is paste, which is allows you to copy and paste code, because the one thing that REPL does is it sort of is eager about determining when you're finished typing something in.
Yeah. So the problem is that when you're typing an expression, Scala's always looking for the moment that it can do the work. And sometimes, in particular, if you define something we're going to get to later, which is companion objects, classes with companion objects. Companion objects need to live in the same scope as the trait or the class that they're companions to. And the problem is, if you try and do that in the Scala compiler, the Scala REPL, it eagerly handles the class first, and then when you define the companion object, it's actually in a different scope. It's that whole nested scoping thing. So if you put it into paste mode first, you actually get that whole chunk of stuff evaluated in one go. It's all in the same scope, so then it works.
And then you hit Control-D to finish.
Yeah.
I have to use very large gestures so they can see when I'm hitting
Control-D. That was a Control-D.
And boom, I get them all at once.
Yeah. So that's that one. History is worth showing. History gives you the history that you've been, the things that you've been typing. You can use that to, quite often I'll get into the REPL to solve a problem. I'll figure out exactly how to do it, and then I'll use a history and copy that out and paste it into an IDE window and use that as sort of the basis to my solution method or something like that. And you can do history 500 or something like, well, not 500,
I'll say 5.
Yeah, okay. So you can have as many lines come out of that as you want. Load, :load will load a file if you've got one. I don't think we have at the moment. But
I have an empty one.
Ah, there you go.
So that worked.
It doesn't have anything in it, though.
Yeah, that's interesting. That nothing is a valid Scala program. I didn't ever think about that just now.
But that will actually load in a Scala file if you've got one and interpret it. And then there's also replay. And what replay does is it resets your session So it's like coming into a clean REPL again, and then replays all of the successful commands that you've had. The one exception, and the reason we see an exception or an error come out here, is it doesn't reevaluate colon commands. So the fact that we use the colon command to get the list of files, that never happened. So then the things that are replayed after that rely on stuff that actually isn't there in the REPL, which is why you see those errors. But if we create something else, yes.
Yeah, greeting equals ho, I change it, and then if I say colon replay, it will actually...
It replays that. It resets it and then replays it. Sets it and then replays it. Okay.
Okay.
What's next on the... okay.
And if...
Okay, so Java's if statement. Let's look at some of the...
Oh, just going to make one comment about the REPL. The REPL is just really handy, even if you're just programming in Java. You can just try stuff out and trying to remember, get a regular expression to work. Or there's all kinds of times when you just really quickly want to try stuff out. You don't need to have to say public static void main, etc. You just type it in and get it to work. And then you can paste it over wherever your source file is.
Yeah. So actually, that's a good point, because particularly if you use something a build tool like Maven or SBT, all sorts of different ones. Gradle, I'm sure, has this. One of the things that you can do is you can bring up the Scala REPL with all of the libraries and all of your class files from your project all ready to go in the class path, which means that as well as just trying stuff out with the regular Scala libraries, you can actually bring up a console that lets you mess with your project interactively. And that's really useful. I've used that to develop things like, if anybody's worked with RESTful APIs, you probably know how kind of random that can be to try and get the results that you want out of a website. It's much easier to do if you can just have all your libraries available on the class path and just start typing commands until you get the thing that you actually want out of the out of the RESTful API, and then you just say, oh, history, and you copy all that in, and you've got your basis for a REST client or something like that. So very useful. Also messing with databases, CouchDB, and parsing the results of JSON queries, and just all that stuff you can do really easily on the command line. So it saves a lot of time. Okay, so let's look at some differences. Quick show of hands, don't be shy. Most people here Java? Java people? Okay. Ruby people? Groovy? Let's see, Clojure. Yeah, a couple of Clojure people. Okay. I saw most hands go up for Java, and I think most people here will have some kind of concept of Java and its capabilities and stuff. So we tend to do this training for mass market, and we tend to do it for people who are coming from a Java background. So a lot of our comparisons are with Java. But I think, you'll be able to get the hang of what we're talking about, even if you're, primarily a Ruby or Groovy or Clojure. Or
if you're one of the two Ruby people?
No, I think there were more than that.
Oh, okay.
I think we've got to be careful.
I think they were boycotting.
They are, but they're tough, so they'll beat us up if we give them a hard time. So Java's if statement is just that. It's an if statement. Okay, in Java, when you say something like if A is greater than B, then print A, else print B, that is a side-affecting statement, okay? It's whatever we put there is going to be done in the case of that being true to start with, or being false for the second statement. And it's something that, in order to have any meaning, it has to have a side effect. It has to change something. It's got to either do input-output like this does, or it's got to set a variable to a new value, something like that. Otherwise, there's not really much point in doing it. Around that, something that's become sort of more, I guess, more fashionable or more accepted as good practice is the ternary operator in Java. And the advantage the ternary operator has is that it is an expression. It has a return value. So it doesn't have to side effect something. You can do something like this to get the maximum of two numbers. You can say, if A is greater than B, then A, else B. It's a bit of a cryptic syntax. It always amuses me that a lot of people think that Scala went too far with making its syntax very, very condensed and stuff like that. If you look at the ternary operator, if you were coming in it cold, you would have no idea what that does. It's just a bunch of operators in a row, but we're just used to it. It's familiarity. So that is doing basically an expression. It gives you back an answer. It doesn't have a side effect.
So the side effect What it means is it has to do something, change something outside of itself. So if is the statement here, and in the top one it's sending out I/O. In the bottom way it doesn't, it just returns a value. So it evaluates it and returns something without changing anything outside of itself.
What it does is creates a new thing.
And then the next line, of course, the print line has a side effect.
Yeah. Okay, so Scala actually combines both of these into one expression, and it can be used either way. So you can choose to just ignore the return type in a Scala if statement, in which case or in a Scala if expression, in which case it looks exactly the same as. In fact, if you can it's exactly the same as. In fact, if you can go back a slide. And I will show that,
and I have to do this with paste here.
Okay.
I have to demo paste because
you can actually put in
prematurely think that after I finish the if, you don't have to have an else, right? So the rep will say, okay, you're done. So if I want to have this whole thing in there, although I'm not, yeah, that should work. Let's see if that works. Control D. Oh, it doesn't know what A and B are. Hang on a second. A equals 1, val B equals 2. So let's try that again.
Do it again.
Paste. Control D, or Control V, Control D, and we get a 2.
So that what you saw before, the Java code is actually valid. In that case, it's actually valid Scala code. If you can go back to that slide really quick. That is the if statement. That if statement there is perfectly valid Scala code. Now, normally you don't see the semicolons because they're optional. They're inferred pretty well by Scala. You don't tend to see a lot of stuff like system.out because printline is actually available to you just right there. You don't have to put a system.out in front of it. And you also tend to put things more on one line in Scala. It's just a style thing. But it's perfectly valid to write that code as Scala. But it's also perfectly valid to write it this way as well. So there's the Scala expression. Okay, so basically what we're saying is that Scala combines the two. The ternary operator happens to coincide with the regular if expression. There is no separate syntax for that. There's always potentially a return type for if, just in the same way, and we haven't covered it yet, but try expressions are the same. They can return a value. So again, in Java, try is kind of an inherently side-effecting thing. In Scala, try can have no side effects. It can return a value from inside of it. And it may return a different value if there's an exception. So it's sort of like an if statement, but it's catching an exception and returning a different value based on the control flow.
So you can see the difference here in what happens after I type it in. The first one, it actually gives me a type with a value, and the variable m has a type and a value. But down here, actually, let me do it this way, just because that's not a good test. Let's get rid of the m. So now, this one is an if that doesn't have a side effect, so it gives me a res4.
Yeah.
Now, the first one actually just has a side effect, so there's nothing coming back, kind of like void. So,
yep.
So that 2 you see there is actually being printed by printline.
Kind of like void.
Yeah.
Yeah. So what's the next slide?
Okay, it is.
Okay, defining function. So now we've done our kind of initial investigations. We'll actually define a function. So this looks a bit different from Java. In fact, I'm struggling to remember exactly how you do this in Java now. It's been a while. Public, it would be a public, then return type, then the name, and then the parameters. Yeah, that's right. So in Scala, what you get is you get a keyword called def, which is your definition, and then you give it the name of the function. And again, Scala is very consistent in putting the types at the end rather than at the beginning. And part of the reason for that is with type inference, that makes more sense because a lot of the time you don't actually need to put the type in there. So you would just have val x equals 5. There's no type there. It's all inferred. So you don't have to put it in. Whereas if you had int x equals 5 in Java, you've got to put the type there. You can't really miss it out. You've got to have something to tell it, well, this is the definition. This is actually creating one of these things and putting this in it. But anyway, so the def has a name. Then it has the parameter list, and the parameters are listed with types. And this is one of the places in Scala where you can't miss out types. The parameters always have to have types defined because they're part of the signature of that function. If you just defined x and y, if you just said def add x comma y, what are x and y? you have no context on which to base any knowledge of what those things are. So you need to supply a type to say, well, they're ints, so I can add them together or compare them in this case. And then optionally, you can supply a return type. So there's a return type there of type int, and what this is going to do is it's going to take the if statement that we had before. The next thing to notice, though, is that there's an equals after the int there, after the return type. And what this means is that this is going to return some kind of value, and whatever is last to execute in this code, that's going to be returned. That's going to be evaluated and returned from this function. Okay? So although it's there in Scala, it's not idiomatic to see return calls. The key word is there. What's much more idiomatic, it's more of a functional programming thing, is to see an equals there, and it will simply evaluate the last thing to happen in the code and give you back that result. So the equals means that we're giving something back, and then we put the same code that we had before. If x is greater than y, then we're going to give back x, else we're going to give back y. We're going to give back x, else we're going to give back y.
Okay, try that.
And when we do that, we get a new definition of max with x of y, x of int, y of int, and it returns an int.
Yeah, this is kind of its type signature. This is the parameters and the return type all squished together. But now I can say max 3 comma 5. I get a 5 and
swap it around.
And 88 comma 0. I should get 88 if I get rid of that.
There we go.
Print.
So that works. Okay. So this is what we would call the kind of the wordy or the Java way of doing this. There is much more streamlined options available for Scala. And one of the things I found really liberating about coming into Scala is in Java, we've become very particular about laying everything out, not always having open and closed braces and stuff like that. And there's a lot of ceremony around it. I think part of that is to try and avoid the signal to noise ratio getting so high that the noise drowns out the signal. By staying very rigid in the way we define stuff, it helps people read the code. But with Scala, there's much less noise in the first place. You've got rid of a lot of the types and a lot of the stuff that you normally see in there. You can get rid of a lot of the boilerplate. So it's quite common to see people do something like this. Oh,
yeah, sorry, go ahead. I was trying to highlight it.
Like a streamlined function like this. So if it'll all fit on one line, why not put it all on one line? So you just have def max 2, x of int, y of int. We miss out the return type because it can be inferred. And then we just say if x is greater than y, x else y. Greater than y, x else y.
So all on one line. Def max, I'll just call it plain old max, x colon int, y colon int. And there I leave off, I could say colon int, but I can leave that off and that will be inferred. You can't leave off these guys, as Dick said.
Because it doesn't know what they are inside of the function.
But then I can just say if x greater than y, x else y, and that will see it inferred to be int right here.
And what you'll notice is the type signature of this is exactly the same as the last one we defined. This code is identical to what we saw before. It's just a lot shorter. There's a lot less pomp and circumstance about it. So.
And one thing I like to do is show that, do you remember in algebra, this thing f of x equals x plus 1, like a successor function?
Yeah.
What you could do to make that a Scala method is put a colon int on this thing and then just put a def in front. And now I've got a Scala method that when I pass 2, it gives me 3. So it's going to give you some insight into where the syntax comes from.
It's like mathematics with just a minimal amount of syntax added onto it. Okay.
Okay, goal to quit.
Okay, Scala scripting. So Scala gives you the ability to actually write scripts in Scala code. You can do that by simply creating a file with something like this in it. And when you write a script, you don't have to put public static void main or any of that kind of stuff. You just start writing Scala code.
Oh, that's horrible.
And the command line parameters are available as args to you. So
Okay, so I have that in. Oops, I have to get rid of that. I can't even see this myself. I don't know what happened to my colors one. But anyway, now we just have a comment in this file, and comments look just like they do in Java, and a print line. And then arg0 is actually defined in a script to be what this passes command line. So you can say Scala before. If you just say Scala, you get the REPL. If you add a file name, that ends in .scala, it's going to try to interpret it. So what it'll do is it'll read it in, compile it really as quickly as possible, and then execute it. Kind of wraps it in a main method, and then of course I'm going to say world or something, and that is my. See how quickly it compiles, and it says hello world.
Yeah, very good.
With an exclamation point.
Okay.
So scripting is actually not a bad way to like start learning Scala. That's how I did it. As I had to write, I was writing scripts anyway now and then to do stuff, parse files or whatnot. And since I didn't know the language, I thought that was kind of a low risk way to start.
The only thing I would say is it's not the amount of time it takes to start the Scala interactive libraries and everything like that, bring it up. You're not really going to be writing things like ls in it, because there's about a half a second lag before it actually does the thing. It's got quite a lot of stuff that it has to do behind the scenes. So it's good. It's a good way of learning it. It's not really good for writing Unix tools or anything like that at the moment, but that's okay. So okay, next up, while loops. So while loops exist. They're not all that common to see in idiomatic Scala code, but they are very performant. So the reason they're not often seen is in a functional language, you seek to try, when you're writing in a functional style, you seek to try and avoid side effects. And the problem with a while loop is it inherently has to have a side effect to do anything useful. There's no return type, so it can't create anything new without making a side effect. You have to create a var outside of it and assign the var or something like that. So yeah, what's...
I don't know. I think I have a 1, 2, 3. 1, 2, 3. There we go. I must have had a typo in my name or something. But
okay. Okay. So yeah, can we see the slide again, quick? Thanks. So the var is you need a var for the number of for the iterator to count the number of arguments. You need to do something like a print line or an assignment inside of the while, all of that kind of thing. And it's just side effecting code. It's not wrong. And in fact, a lot of the time you'll see inside of the libraries, the core libraries and stuff like that, you might actually see while loops in there because they're very performant and somebody's put a lot of effort into making sure that they behave correctly. But the functional style would be to use a different option, which I think is probably the next slide.
Yeah, so one point I just want to make is if does have a result type, right? If you can say if A greater than B, A else B, that has a result that's an int. While never does, so it has to have a side effect.
Okay, so this is a bit more idiomatic to see in Scala, is to use a for expression. And for in Scala is actually an expression. In this case, we're using it as a statement. But for can actually return results as well, which means that it doesn't have to have side effects. It can be purely functional. And what we do in this case is we just say for arg from args. And the right arrow I read as from, or in, is a good mnemonic for that. So for arg from args, print line arg. And that does the same as the while loop that we just saw. It's the same as the while loop that we just saw. So this is much more idiomatic. This is much more likely to be seen in the code. Yeah, so Bill's creating an array.
I'm not in the Scala prompt. Shell doesn't know how to deal with that.
There we go.
Well, I want to get the 210 one. Where the heck is it? There it is.
Okay.
Val args equals. I'm going to make an array 1, 2, 3 because I don't have args. I can say for arg in right arrow.
Yeah.
Args print line arg. 1, 2, 3.
Now something else we can show at this point because I'm not sure. We'll mix it up a bit. I mentioned that you can return you can return values from for. So why don't you go ahead and just yield arg times 2. Okay, so in this case what we're doing is we're actually giving back values from this. And so this is no longer a side effecting loop. This is a purely functional loop now. It takes the inputs and it creates a new array with that operation applied to each of the arguments from the original, or each of the values of the original one. So we get back 2, 4, and 6. And this is the way you'll see most idiomatic Scala code written, is it doesn't side effect inside of the body of the for expression. It yields some value instead, which creates a new collection and hands that back to you. And that's very functional. You don't affect the original. You don't have side effects. You create new stuff that has the new values in that you want.
And kind of the idea, I think, is that In Scala, it's a blend of functional and imperative. And imperative is the style of where you mutate variables, you have mutable objects, you have side effects like I/O and whatnot. And you got to have those somewhere in your program, otherwise you can't get any, it won't change the world outside of itself. But what you tend to do is try to have most of your program more functional style because it's easier to test and it's easier to reason about. And then isolate the side effects more in one area. So that, again, you can see the for on top doesn't have a return type. It's just you're seeing the output of the print line there, whereas down here you got actually, it assigns it to a variable and you've got an array event type. So kind of the functional way is you start with something, some data structure, and then you transform it and get another one, and then you transform it and you get another one, you transform it and you get another one, and then you transform another one, and then you transform it again and you get what you want.
Yeah. Okay. All right, looping with for each. So what we just saw was a for expression, or sometimes I call them for comprehensions. I think the official line is that they're called for expressions because comprehension sounds a bit more grandiose or something. But in Python, they'd be called a for comprehension. What actually happens behind the scenes with that, the for is a pretty wildly powerful language construct in Scala. And what the Scala compiler does is it takes those for expressions and it turns them into a series of calls to functions like for each or map or filter. All these things that you can use yourself behind the scenes. For will turn things into that. So here's an example. That one that we just wrote, the for arg from args, the for arg from args, that can also be written as this. And in fact, when you type that into the Scala compiler, it makes this code. So in this case, we'd actually get a for each. Yeah. So
that one turns into this one.
Yeah, that one turns into this one.
So you do the same thing.
Yeah. And what this is doing is it's saying for each of the things in that collection args, give it to me as an arg. And this is the first time you've seen a function literal in Scala so far today, which is
this thing.
Yeah. The first thing there before the rocket, before the equals greater than, is the incoming parameter. So it means give me that item named arg. And then on the right-hand side of the rocket, you get to say what you do with that. So we say print line that thing. And
so just to do it one little step at a time, args is an array event, and args, if I say, oops, args, dot, and say f, and then tab, it's going to say what are the things that are there, and it's not working for some reason. Anyway, for each is a method on args. It's a method on array. Yeah. That you can call an array in Scala. And then you can pass something into it, right? You can pass a parameter in, and the parameter is a function literal. It's this whole thing, print line arg. Yeah. So this is the, I'm just going to space them out here so you can see that the actual parameter I'm passing in is this whole thing. That gets, that bit of code creates a class that has a method on it that is used to invoke the function called apply. And it just creates all that stuff behind the scenes and creates an instance of it and passes it in right there. It's like a one-off, oops, I have a typo. There we go. Okay. There we go. Okay. It's like a one-off anonymous class instance. What's next? Just these. Oh, okay. So looping. Yeah. So this is the kind of full. What do you call it? The fully wordy version of for each. This one is. Yeah. In fact, there's an even wordier one, which in this case, in the top one, arg has a type. Everything has a type, but the type can be inferred because the Scala compiler knows what we're iterating over. It knows the collection that you're coming from is, in this case, an array of ints. I think it was. Array of string. The arg's in a. Yeah, but your one was an array of ints. Oh, mine was an array of ints. Yeah, that's right. So it knows what you're getting in, so you don't have to specify it, but you can. In the case of args being an array of string, you can actually specify the type, and Scala will enforce that, and it will be a compile error if it's a different type than you think it is. Yeah. So you can do the... It would be a compiler error here, because my args is something else. Yes, that'll be a... Yep. It found a string to unit and required an int to something, so there you go. That's a compiler error. But there are actually kind of more concise ways of doing it. One of them is this this form. Since we know that we need a function that takes exactly one argument and does something with it, println actually matches that. So Scala doesn't make you name the parameter
and then use the parameter in the function. It just says, oh, well, you've got one thing coming in, and this function inside of it takes one thing.
Yeah,
I can connect the dots. I can figure out that what you actually want to do is pass that argument into the function internally. So it just takes each of those items from args, and it calls printline with them. And then the final kind of step of this.
So instead of a dot, I put a space for each, and instead of a parens, I just leave those parens off. I can do it that way too. Whoops, printline.
Yeah. And this is infix notation, so we can show this quick with plus.
Yeah.
When you do one...
I'm going to say 1 plus 2.
Yeah.
Right.
So that concatenates the two strings. Now, if you say 1 dot plus parens 2, these two are actually equivalent. They're completely identical in terms of what the Scala compiler does with them. It's just that Scala knows that if you have an instance of an object followed by a method followed by a single parameter, you can choose to call it with a dot and parens, or you can just leave the dot and the parens out and use it in what's known as infix notation. And that's just a general rule. So you can do it with plus. You can also do it with things like for each. In this case, for each takes a single argument or a single parameter. It works on an instance, so we can leave out the dot and the parens and just call it infix.
So here's another example, caret, right? Caret 2 on 1 is E.
Yeah.
And I can leave off the parens and the dot and call this in infix notation. You can call any method in infix notation. Yep. It's not just methods that have operator symbol names like plus.
As long as it has one parameter. And it doesn't work with more than one parameter.
Yeah. If you have more than one parameter, you can still use the spaces, but you've got to put parens around the multiple parameter list. So the thing is, Scala is, one difference about it is it doesn't have, it tries to have fewer special cases than I think most other languages. So there are no operators in Scala. Every other language I've looked at has a list of operators that are supported, and plus is among them. Scala doesn't. It just has objects with methods. Everything is an object. Every value is an object, and every operation is a method call. But you can have methods with operator symbolic names like plus, and then you can call them any method, not just those with operator infix notation.
Okay. All right, function literals. Quick look at these. So a function literal is much like it's an anonymous function. So we've seen so far definitions of functions with a def, but when you use a def, you've got to give it a name. If you don't need a name, and there's lots and lots of cases where you don't, you just make an anonymous function or a function literal. And this is an example of the syntax of that. This is a fully formed function literal. It just doesn't have a name. So if you let's show them this. So if you do a def add, or just make it a def add, and take away the rocket. So this is what if you wanted to make a function that added two numbers together, this is how you'd write it, just from what we've seen so far. If you don't want to give it a name, then what you can do instead is just get rid of the name and the def, and then you put the rocket in where the equals is, and that's the difference. Okay? The rocket signifies this is actually a function. It's a function without a name.
And it happens to be called res15.
Yeah.
See, that's it. So I can call it by the usual way. 1, 2 gives me 3. So once you have a reference to a function literal, you can call it by applying parentheses to it,
right?
Passing arguments.
And more importantly, and this is the really key thing, once you've got a function literal, you can pass it around like it's a piece of data. So you can pass it to other functions, and that's really the cornerstone of a functional language, is being able to pass functions into functions. When you do that, they have a fancy name that you've probably heard. It's called a higher order function. What is it? A first order function is just anything that takes a piece of data, like our add 2 and 3 is a first order function. For each takes a function inside of it, and it's a higher order function. It's a function that takes a function. That's all that means. Okay. And we've got, okay, that's the end of...
I just wanted to mention this. I would be
We're going to liberally sprinkle a few ads in our stuff.
Yeah, if you care. This stuff's all based on this book, and it is, there's a DevOps discount at that Computer Manuals site, which should cover the shipping costs. So that's the end of this one.
This is where we'd normally do exercises, but...
so we're going to, I think, we should keep going until have a halfway break for some questions,
Okay.
and then we'll have some questions at the end too. Just otherwise, there will be too.
So we'll at least do the next steps.
We'll time limit it so that we have.
I think we should at least do the next steps. Do you want to fly again, or do you want me to?
I know I can fly.
Okay.
We can take turns, unless you don't want to use my. I'm fine with it, but probably we should take turns.
Okay, sure.
Just give people variety.
I can use your machine.
Yeah, better than I can use yours. I'm notoriously bad at using his laptop. Okay, so we're just going to continue this second module here.
Where have you got your? Is it just? Oh, there we go. Yeah. Okay, got it.
And there's a Sublime also.
Oh, okay.
That you might prefer. That's 2.9.
Okay.
Okay, so slide, please. I don't know why.
Oh, sorry. I was getting Sublime set up. There we go. Okay. Parameterize.
Yes.
So,
there are. We want to show you the idiomatic. Well, this is actually an unidiomatic way to create an array. That very first line where it says new array of, in square brackets string, and then in parentheses an int. The thing in parentheses is the value parameter. So when you instantiate a class, you can parameterize it with values. That's the things you pass into the constructor. The thing in square brackets are the type parameters. You can also parameterize it with types. And so an array requires a type parameter that says the element type. In this case, it's an array of strings.
I am just bringing up the.
Yeah. So see, I say I'm going to create a new array of strings. That means I can only put strings in it, and the number there is the size of the array, right? So then I can do. I can stick values into the array with this greet strings of 0 equals hello, and the thing you'll notice there that's different from most languages is Scala does not use square brackets for array access. What it uses square brackets for is type parameters.
Yeah.
And we'll talk about why that is the case, but just for now, that's a difference. So I say greet strings in parentheses 0 equals hello, blah, 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 and now I've actually populated my array. And then when you run that for loop down below, it prints them out, I think. What does it do? I can't see the, there you go.
Them,
oh, yeah,
yes.
Prints them out. So the way to access the element of the array, again, is you don't use square brackets, you use parentheses. So greet strings and then parens I.
Yeah, so greet strings, I can now say greet strings 1 equals.
Oops.
And then if I now do for I, actually, just copy this and paste it. Then we'll get something different back. Now it says hello dash 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 world. So what we've learned from this, amongst other things, is that arrays are mutable.
Yes.
You can change the contents of them.
Actually, arrays are Java arrays. That is Java arrays. That is exactly a Java array when you use an array in Scala. So let's go to the next one.
Okay.
So one of the things that we already talked about that, yeah. So this is just, let me just say that at the bottom, when I say 1 plus 2, I get 1. I'm calling the plus method of 1 passing in 2. The reason I put parens around these is
don't tell them. Let's see who's awake. Who knows why there has to be parens around the
there's got to be
here.
Someone awake if this many people is here.
Carl, you've seen
no,
this
you
before.
Can't.
You can't.
You
can't
can.
Answer.
He's just too eager. Yes, this guy. You're not too eager.
Well, yeah, in a sense. No. If you just do 1 dot...
That's actually correct.
It assumes it's a floating point number because 1 dot is a valid floating point number. So it then actually works, but let me show you what it does. If we say 1 dot plus 2, we get back an int 3. If we do 1 dot plus 2, like this, we get back a floating point because the first, it's valid to do that, but the first one it thinks is a double. So yeah, that's just a little kind of puzzler for the morning there.
Okay, want to go to the next slide? Next slide. Normally we have 2 laptops, but that, I guess they don't have that technology over here. So
there's only 1 laptop in the whole conference, I'm sure.
Okay, so one of the things that I guess I want to try and describe about how Scala is different is that most languages will have a lot of special cases, like there's a special set of primitive types, there's a special set of operators, things like that. Scala doesn't have that. It has rules that are applicable everywhere. So it has a bunch of things you got to learn, which are these rules that are applicable everywhere, but it's different that way. So one of the things that it does is it has a number of rewriting rules. When it hits a certain kind of syntax, it will rewrite it to another. So
yes, so here we were showing that, your scroll's the wrong way around. So greet strings, if you do greet strings parens 1, that actually gets rewritten by the compiler to greet strings.apply1. That's true for any object. If you call parens with a parameter after it, it gets turned into a .apply call. So these two calls are identical, greet strings 1 and greet strings.apply1. And when you know that, you can make very natural looking syntax. So that's how access into arrays works, is it calls the apply method on that. And an example is if I create a string and I say, give me the third character of that string, I get char. The way that's actually done is like this. There's an apply method on the string, and I can say s.apply3, and I get the character out of it. And you can do that to your own objects.
Looks
so
like
you
a
can
one.
make... Oh, sorry. Bad choice.
Yeah, no matter what you do, other than apply itself, if you put parentheses next to something, the compiler will rewrite it to it'll stick a .apply in the middle.
And also, when you do something like greet strings 3, no, not 3, because it's not as big as 3, equals
something that doesn't look like
YAWL,
1.
then that is the same as saying greet strings.apply, no, update.
Yep.
And then 2, YAWL. So that gets rewritten to that. So again, you can do your own kind of access into things.
Yep.
That looks very natural. It looks part of the language, but it's just done through a rule.
So the difference is, so it doesn't have that special syntax for arrays. What it has is a general rule that works on arrays, but works on anything else, including what you write. Right? So you can get this kind of syntax in your own types if you want.
Right.
Okay. So the actual idiomatic way of creating an array is this way. What was wrong with the previous one is it's easy to have off by one errors. You could accidentally hit the, like try to initialize an empty array, and then, you create an empty array, and you initialize one past the end. What this does is you say capital A array, that's the type of array in Scala, and then you put parentheses next to it, and stick initial values in it, and it will count how many you pass in. And make that the size of the array and return an array that's initialized. So,
and if you do a .apply, there's nothing about apply that says that it can only take one argument, so we can have an apply with as many arguments as we want, and that's how that works. That's what that's doing behind the scenes.
In this case, apply is takes a var args.
Yes.
Right. So it's just a method on this thing called array. You can think of it as a static method.
Something
on
else
the array
worth mentioning.
That is named apply and takes var args of string.
Something else worth mentioning here is that the Scala type inference is still working for us here. So if we do an array.apply of integers, we get an array of integers back. If we do an array.apply with 2 integers and a float in, we get a double, because all those things can be treated as a double. If we stick a true in there, we should get an any val, which we'll get into the hierarchy later. And then finally, if we add a string in as well, then we get an any. And any is kind of the object of the, actually any ref is object. But this is the thing that's at the top of the hierarchy. So Scala gives us a collection that's type consistent with whatever you pass in, and it will try and make it as specific as it can, but it will always infer a compilation correct type to use.
Okay, so what he has there is, again, coming from the Java perspective, it's a factory method, right? I've got a static factory method on the array class. In Scala, there actually aren't any static methods, so what it has instead is called a singleton object, and whenever you call into a Java method, you are calling actually a static method, so you can call any Java method, but it looks like a singleton object exists. And what that is just what it sounds like. It's the gang of 4 singleton pattern, where you have one and only one instance of something. The name of the reference, there's one reference to that thing, which is capital A array. That's like a reference to an object that exists, and I'm calling an apply method on that, and that's my factory method.
It doesn't matter how many times I call that, I'm always going to get the exact same instance back. That one.
Okay, so I think that's good for arrays. I think now what you'll see is that the way you saw that we created an array is very consistent with how you create any collection. You say the name of the collection, and you put parens, and you put in initial values.
Yep.
So there's something called a list in Scala, which is a linked list, and it's an immutable, purely functional data structure. And to create one of those, I just say list, and then in parens I pass initial values. It will infer the type and give me back a list of that type with that stuff in it.
Yep.
To create a set, I do the same kind of thing.
And if I create a set with many different things in, of course,
it does the set thing.
Yeah, it keeps it unique. There's also all sorts of other things that you can do. Vector is an important one.
Actually,
nothing to do with the vector from the old Scala days. This is good vector. This is very good vector.
Vector is an immutable data structure that has fairly good performance characteristics. List is an immutable data structure that you have to be careful how you use it. If for large collections, just accessing an element, it could be linear time, right? Because it has to traverse the whole list. So list is really good for functional algorithms, but in practice we tend to use vector now most of the time instead of list.
List is excellent if you can always work at the head. It's extremely good performance if you always work at the head. If you add to the head and take off the head, it's great. If you ever found yourself indexing into it or using something from the end, probably want to use a vector instead. Okay?
Yeah, I think just by default you should probably use vector, because even though you don't want to access an element, or not work at the head, it's just easy to do so in practice. So so what was on the slide? We were looking at...
it's this code.
Oh, this one, yes. Okay.
Oops.
This demos that list is immutable. I create a 1-2 list and a 3-4 list. And this little triple colon operator is concatenate. So I'm taking 1-2 and I'm concatenating 3-4. And what I get back is a new list with 1, 2, 3, and 4 in it.
But the original
lists are unchanged.
Yeah, so if I look at 1, 2 here, that is still 1, 2, and 3, 4 is still 3, 4.
So this is like strings. If you concatenate two strings together in Java, you get back a new string with the new value. And that triple colon operator is concatenate right there. It takes two lists on each side. The double colon operator right there, you see, is called const, and that takes an element on the left. So I can const a new element to the front of the list. That's the constant time operation.
So if I do 1, 2, 3, 4 here and stick a 0 on the front of it,
that's a good idea.
Then I get 0, 1, 2, 3, 4. But again, 1, 2, 3, 4 hasn't been changed.
Okay.
1, 2, 3, 4 hasn't been changed.
Okay, so you remember how we said that there are no operators in Scala, there's just methods and objects, but methods can have operator symbolic names. So that's what this is. The thing is, though, that there's another special rule that works everywhere that you have to learn, which is that if an operator or a method name ends in a colon, it's actually right associative. Otherwise, it's left associative. So when we called plus on 1 and passed in 2, we said 1 plus 2, passed in 2. We said 1 plus 2, 1's to the left. It calls the method on the one thing to the left. In this case, it actually calls the method on the thing to the right.
Yeah.
So the list is to the right, and I need to call the const method on list, the double colon method on list, and pass in the thing to the left.
See, if I try it the other way around, this isn't going to work. Because the colon, int doesn't know what colon is. There has to be a list before you can do that. So that's why it works the other way around in this case.
So yeah, so when I say 0 const 1, 2, 3, 4, only because that const operator ends in a colon, no matter what it was, as long as it ends in a colon, it would do this. It calls the method on the thing to the right and passes in the thing to the left. Okay, left. Okay. And that means another way to create a list is like this. So this nil is not a keyword. That is a singleton object, the one and only one empty list. So starting with that, I can const a 3, and then to that, I get back a new list with a 3 in it. And then to that one, I const the 2. I get back a new list with 2 and a 3 in it. And to that, I const the 1. I get back a new list 1 to 2. So it goes right to left. And that's another way to get a list.
Yep. Okay. Converting between.
So there are a number of conversion methods that are handy. ToList, ToArray. 210 has 2 vector,
yep.
And 10 has 2 vector. Yep. And there's just basically, if you need a set or a map or whatever, you can often convert to them by just.
And in fact, there's also a new trick in 210 where you can create
any type. Yeah.
Any type with this form. You just give it a type parameter of the type that you want it to go to. So 2 vector, I can do a 2 hash set. Oh, maybe I need to import that. Just 2 set should work, shouldn't it? Yeah.
Yeah. I think you say 2 set without it, but so basically, normally you wouldn't need that because you just usually use the out of the box set and map instance. But if you created your own, or you're using more of a rare type or something that you want for performance characteristics, you can actually use that square brackets form in 210. So I'm going to go to the next one. So tuples. Tuples aren't really collections. They're not in this hierarchy of collections, but they're the same kind of concept because they hold. Objects. And what they're used for is they're useful for a lot of things. But if you ever are writing a method and you want to return more than one thing, in Java you got to create a holder class called int and long, int and string or something, name and age, and what you can do in Scala is just take those 2 things and put parentheses around them and return it. And that creates a tuple of those 2 things. And the tuple has a type that includes the number of elements in it. So if you have 2 things in it, it's a tuple 2. If you have 3 things in it, it's a tuple 3. A tuple 2 has 2 type parameters. Tuple 3 has 3 type parameters. So it just keeps track of the type of each element. And they can be different. That's how it's different from a collection, like a list. Right. A list has 1 element type. An array has 1 element type. Everything in there is string. If you have heterogeneous things in there, then the type of the list is any, as Dick showed.
Right.
So it has to be like the lowest common supertype of everything. But so if you say you are the one for me, that is inferred to be char string int string, right? And it's tuple 6. I don't know if you can see tuple 6. Oh, it doesn't say tuple 6, but that's what it is.
And what we can also do is pull that out like this equals t. So we're going to actually pull out those 6 values. Oh, no, not trait, just t. And that actually brings out the original types. So we've now got A, B, C, D, E, and F, but they're all defined with the types that were strongly applied inside of the tuple.
So if you got a method that returns a tuple 2 or something, you can bust them out like that into variables. It's on the calling side.
Yep.
There is. Oh, we should talk about _1, _2. Back up a sec. There is a way also to say There is a way also to say _1, _2. So if you can say t._1, you get the first one. T_2 is the second one, and so on. It's kind of ugly. So usually we will actually not do that. Usually people bust them out with that syntax he showed there, where
much better readability.
Yeah, like num what pair.
Okay.
Okay. Now sets and maps are in a hierarchy, and this is interesting from the Java perspective, which is Josh Block had this page called the Collections FAQ. I don't know if you guys remember that, but back when the new collections came in, and he was primarily the main designer for it, he said that one of the questions people kept asking him, why didn't you model mutability in the hierarchy? And he said you end up with this combinatorial explosion of names, because you can have the mutable set and the immutable set, and the mutable synchronized set and the immutable synchronized set, and there were like 3 different ones. You got this big explosion of names. So Scala does do that. It models mutability in the hierarchy. But what it does is it actually gives everybody the same name. That's how it deals with the explosion of a combinatorial explosion of names. So there's actually 3 sets, 3 classes named set, or traits named set, but they're in different packages. So the Scala collection package is the level of abstraction of where it can be either mutable or immutable. It could be either one. And so it has methods that make sense for both. And then there's an immutable, Scala collection immutable package where it has only immutable types, and Scala collection mutable that has only mutable types. And you can see they inherit from the general one. And then there's like two hash sets. There's an immutable one and a mutable one. And one of the things that is, Scala does nudge you towards a functional style, but it lets you do things imperatively when you need to. It makes it really easy. But one way, for example, that it nudges you to the functional way is that when you just say set, you get the one on the bottom left there, the immutable set. So when Dick said set earlier, he got an immutable set.
Yeah, if I say set
1, 2, 3, that's going to be immutable. To get the mutable one, all you have to do is import the other one. And yeah, why don't you show importing the whole immutable set?
This is really the kind of idiomatic way to do this, because you don't want to import the mutable stuff directly into the namespace, because then when you use it, people reading your code don't know that you're using the mutable collections, and that's usually a bad thing. So what you tend to do is you import the packages, and by saying import scala.collection._, I'm bringing in, actually I could just say mutable here.
Yeah.
And I'll just bring in the whole mutable package, but I'll leave it named mutable. So now if I want to use that, I can say mutable.set 1, 2, 3.
Yep.
And that is much more readable. At the definition site, whoever's reading your code gets to know that this is a mutable set. And they probably shouldn't do lots and lots of threaded stuff with it.
Yep. So that's one difference between Java and Scala is you can in Scala import package names. In Java, you can only import type names. So what he did there, when he says Scala collection mutable, that's the name of a package. So the word mutable now means Scala collection mutable. So when he says mutable.set, that means Scala collection mutable.set. And that is the idiomatic way to actually use mutable types.
And now I can refer to mutable. I've just imported immutable, so I can refer to mutable and immutable in the same code.
And so that works in Scala really well. Usually you'll use just the immutable one. If you have a source file where you're mixing them, you'll import usually Scala collection _, which means import Scala collection star in Java. It's just the wildcard import. And then you can just say immutable set, so it's real obvious from the code which one you mean.
Right, this is the...
Okay, what's next?
This is a var with an immutable set in it. So this is the...
Oh yes, another rewrite rule. So I have an immutable set, and I'm going to say plus equals on it. And what happens there is the first thing that the Scala compiler will do is look on the type of that variable and see if it has a method name plus equals. That's a valid method name, right? And it does not, because it's an immutable set type, and you can't plus equal something into that set and mutate it. But it does have a plus method that will return a new set back that has that extra element. So what it does in that case is it rewrites, there's another rewrite rule, your plus equals, set plus equals value to set equals set plus value. And it only works if you are, your variable there is a var. So that's what it rewrites it to, jet set equals jet set plus citation. And the reason that works is jet set is a var. First I basically call the plus method on set, on immutable set, and it gives me back a new set with that thing in it, citation. Now I've got a new object, that's immutable, and I just replace the old reference in jet set with pointing to the new object. So that's one rewrite rule. And if you look at the mutable version, this is different because movie set is referring to a mutable set, which actually does have a method name plus equals. So you can actually mutate that in place. So that's why this can be held from a val. So when I say val movie val, so when I say val movie set equals and I have a mutable set, when I call plus equals on that, it sort of short-circuited that rule. It's the same rule because the first thing it does is it sees if there's a method with that name on it. And in this case, there is. So what you end up with is basically whether you've got a mutable set or an immutable set, so long as the immutable one is in a var, the syntax works the same. When you plus equal something, you get a new set or the same set back with that new thing in it.
Okay.
And that, again, that rewrite rule is general. You can use it on your own types.
I think this is a good time to mention an even more general rule, which is that Scala only does any kind of rewriting, it only does any kind of modification to your code if it won't compile as it's written. So the plus equals that will get applied if there's a plus equals method on an object is the plus equals method on that object because it compiles. If it won't compile, then it will look at whether changing it to an equals x plus whatever will work. And if that will work, it will rewrite it to that for you. And that's the same with all the kind of things that Scala does behind the scenes to make your life easier. Is the first thing it will do is say, does the code compile as it is right now? And if it is, it won't touch it. Okay, it only tries to help you if things aren't working. Okay.
Okay, so this slide is just showing that the same thing works for hash set. You can import that name you have to import doesn't happen to be available because they have a bunch of different, there's a bunch of different collection types. They each have different performance characteristics. Usually the default one is good enough unless you have a performance problem or know you need certain kind. And when you do, you would import it and use it. But it's always the same. You just say the name of the thing you want, and then in parentheses you put the initial values and you get a new one back. Everybody has it's all very consistent. This is what Dick already demoed. If I want to use both in the same mutable and immutable variants in the same source file, we usually import the package. This is very much the same as the set. I've got 3 maps. There's a map in Scala collection, which doesn't say whether it's mutable or immutable, and then there's a mutable subclass and an immutable subclass. And by default, when you say map, you get the immutable one. And then there's like 2 hash maps also. So this is similar, except there's one extra thing. This is actually the non-idiomatic way to make a new map.
I'm going to put this into the interpreter
Once
here.
Once you get that in there, Okay, so when I say map.empty, one of the things you can do if you need something empty is on any type is say .empty. So that's another thing that's consistent. If you need a hash set, you say hash set.empty. Now when you do that, it doesn't have any initial parameters to infer the type from, so you got to give it square brackets and the type. Right? So if you say set.empty, I need to say square bracket int if I want a set of int. In the case of a map, you need to give it 2 types, the key type and the value type. So I would say map.empty, and then I don't know what they were, but string comma int in square brackets.
Yep.
Int comma string in this case. And then I can plus equals, this is probably mutable. Yes, this is a mutable map, so I'm plus equals in elements, and each element is a pair of values. It's a key type paired with a value type, right? And the syntax for that is this one and then a right arrow and go to island. So,
and if you remember, the rule for this is that gets rewritten to treasuremap.apply 1.
Yep. So to access an element, you access it by the key type. It's probably better to have a key type that's not int. It looks kind of like an array. But anyway, in this case, the key type is an int, so I just pass the int in there. If the key type was an elephant, you'd pass the int in there. If the key type was an elephant, you'd pass the elephant in there and get back the value. But as Dick pointed out, it's the same way. So you access an element by calling apply, and you can leave off the .apply. Okay, so what is this right arrow thing?
I'll give you a demo of that. So if you say if we say 5 arrow 5, that gives us back a tuple 2 of string and int. But what's the arrow doing? Is that Bill? Is that syntax?
No.
No. Okay.
Nope. Now most a lot of languages like Java doesn't, I don't think, but Python and Ruby, a lot of languages will have a syntax for maps, right? Scala doesn't have that. What this is you're calling the right arrow method on 5 and passing the string 5 and passing in the number 5, right? It's just a method call used in operator notation. And
so Bill,
yes.
Do you mean somebody went through the entire Scala type system and added arrow to
I hope not, because they might have forgot something, and it wouldn't be on your types either, right?
That would be a lot of work.
There's another way that it will try to fix a type error. If you look on string, it doesn't have a right arrow. String is actually Java lang string, and it doesn't have a right arrow method.
I need to be in this guy for that. 5 dots. Okay, there's no arrow.
Yep. That's just the string methods. Plus, we have plus up there, which is nice. So what it will do is it will look to see if there's that method on that type, and if so, it just calls it. But if it's not there, it has, before it fails to compile and gives you a compiler error message, what it will do is it will look around to see if there's an implicit conversion in scope that will fix the type error. And what that is languages have always had implicit conversions. Like Java has an implicit conversion from an int to a long. So if you have a method that takes a long and you pass in an int, it will implicitly do a widening conversion. So it's a tool that language designers would use, and they put all these hard-coded implicit conversions in their language and those are sort of the special treatment, right? What Scala has is a general rule or general feature that not only does a language designer use to convert ints to longs implicitly, but you can do something you can use them also, right, in your own types. So what there is there's an implicit conversion from anything, any type, to something else that has a right arrow method.
And there it is. It's actually called any to arrow assoc, not the best name perhaps.
No,
but anything you pass it becomes a wrapped instance, and that instance has a arrow, a right pointing arrow on it. So you can now do if I can do res22 great arrow and then say 5. Actually, I changed it. I made it out 5 in the first place, so let's do it that way around. Now I get the tuple back, and that's kind of the demystification of how that is added. Seems like a lot to go through, but it means that you can add something that's apparently a keyword into the language without actually burning up a keyword. It lets you have something that looks like native syntax without reserving and killing a whole bunch of potential keywords or potential things that you might want to use in the language. And
also limiting it to just the preordained chosen types.
Right.
Can you show the slide? Can you show the slide again? I think that might be good to kind of see the sequence here. The first rewrite rule that the Scala compiler will apply is because this is an infix notation on the top line, it will rewrite it to be a method call notation. So that happens while it's compiling. And then it looks up and notice there's no right arrow on the int. So now it's going to look around for an implicit conversion, and it finds one. And we'll show you how to define them. Well, actually, you might not show that today, but there's a way that you can define your own implicits. And all it says is, given an anything, I can convert it to this other thing called arrow assoc. That happens to be the type. And if you look at that thing, it has a right arrow method. So it just calls the method that converts anything to an arrow assoc. So when you call any to arrow assoc, you pass in a 3. You get back 3 wrapped into in this new object, and then invokes the right arrow method on that new object, right? And passes in the other guy, and that comes back with a tuple 2. So that's what's going on when you stick things in maps. You don't actually have to use the right arrow to stick things in maps. You can just pass tuple 2s in there with just put things in parens. But that's the idiomatic way to do it. And
if this seems like a lot of effort to go to, it's, what we're doing here is we're showing you the demystification of the magic. People in other languages, this is just syntax, and they're like, oh, okay, well, that's the syntax. Scala doesn't have a lot of this magic. Everything can be explained. You really don't need to know it to use it. But we thought, a bit of insight as to what's really going on, getting rid of some of this concept that Scala's doing all this magic, and just showing how it applies a simple sequence of rules that are very predictable to give you the result that you're expecting.
Yeah, I mean, the difference is it does have more magic than I think other languages, but it has less special cases.
Yeah.
And the reason is that you can make your own libraries feel very natural and be very clear and not have a lot of boilerplate, because you can apply these rules in your own designs. You can use them.
And this is the win right here, when you get syntax like this without actually having to have syntax like that. You get to write a line that is extremely clear and concise without having to actually have support for those keywords. There are, as far as I can tell, the val and the equals are the only things that are reserved in this statement. Everything else is, map is a singleton object, the parens just gets written to an apply method, and so basically you can create your own classes, your own libraries that have this syntax, or something similar, or something not similar if you want. just be careful with that.
Okay, so this is the idiomatic way to make a map. Not the first one I showed you, where you create an empty one first and mutate things in there. But again, because even if it's mutable, it's better to do it this way because you avoid the possibility of an off by one error.
Yep.
So, okay, so the last thing we wanted to do in this part was kind of try to give you an insight into what functional style means. And really the win is that I think it's a little less error prone. As you can see, like when you transform a data structure, you can't have the off by one errors that you can have when you're going through a while loop and indexing into something. This guy right here is an imperative style method, and it's imperative for one reason, because you can see that colon unit at the end. Scala is a functional language, so that means every method has to have a return type, so it doesn't have a void. It has this thing called unit instead. So what happened to void is it got turned into unit with a big U, and that's a type that is got one and only one instance. So it always returns the same thing because that's the only thing that it can return, which is a pair of empty parentheses, which is kind of like a tuple 0. So you can't really do too much with it. It has to have some side effect outside of itself. And
as an example, what I did here was I did the print line, but I set x to be the value of print line, and print line returns unit. And when you actually stop and think about it, the absence of a return type from a function is not a very natural concept. It's something we've got used to in Scala, but it's really weird not to have, in Java. It's really weird not to have something come back from a call. Whereas Scala's very consistent. You can have something that you don't care about coming back from a call. That makes total sense. But you never have, well, you almost never have nothing coming back from a call. There's an exception when you're dealing with continuations, but we're not going to get anywhere close to that.
So if you just say empty parens and hit return, you'll get a unit, right?
Yeah. Oh, yeah.
Try that. Just say empty parens and hit return. Oh, well, it doesn't. But when you get a
val
unit back, it
y
doesn't
equals,
print it out.
Yeah.
Yeah, back it doesn't
equals,
print it out.
Yeah.
Yeah, you saw that before. Okay, so let's go back. I can't remember what the slide is. I forgot already. Yes. So var is a sign of I'm using imperative style if I have a var. So I set I equal to 0, and then a while loop is also a sign that I'm using the imperative style, because while does not have a result type. Its result type now is unit, right? So here I can have my off by one arrow, but hopefully I don't. I just print out the args one at a time, and I increment I. I mean, that's the old C way I used to do it. So you can do that in Scala. And as Dick said, a lot of times you'll do this for performance. If you got a performance problem and you need to fix it, you make things more imperative to do that. So Scala lets you do that. So one of the things to make it a little more functional is to get rid of that var and the while by using a for. What I have gained there is not only a little bit of conciseness, but also I can't have that off by one error anymore, right? So that is still imperative because the return type is still unit. I'm still printing here. I can also say args for each print line. That top body is just rewritten to this bottom body. It rewrites 4 expressions into calls of methods. It's one of the rewrite rules. So to really make it functional, I need to get rid of the side effect of printing. So what I can do is make something called format args that takes the array of string, but it returns a string that has what would be printed returned. And then I can just print that. So again, I was saying before, you got to have I/O, or you have to have side effects somewhere. What this does is it isolates it to that second line. Yeah. And that makes the first line more testable, right? I can actually call it, look at the output, and assert on that, right? Yeah. So there's still, I guess there's a bit of trying to figure out.
My children come to the Church of Scala.
This is my opinion. I think what Scala really is it's the blend.
Yeah.
And the default is functional. So you should use the functional style by default. So use vals, immutable objects, and methods without side effects as the default. But when you have a justification, then that's when you use a var or a method with a side effect or a mutable object. And they're not evil. They're useful. It's just the default would be do the functional thing. and use the special case when you have a reason. There's lots of good reasons. You use the imperative.
I'll add this much, that I've been working in a field that requires a lot of heavy, dense computation for a long time now. In theory, for comprehensions, or for expressions, sorry, and things like for each higher order functions, in theory they're slower than a while loop because they use anonymous inner classes behind the scenes, and that carries an overhead with it. In practice, I think I've had to rewrite probably less than 1% of my code for performance reasons. Okay, I always use for expressions because they're very readable. And when you get into an extremely tight loop, then occasionally you'll fall back on something like tail call recursion or tail call optimization or a while loop to speed it up. The number of lines I've had to do that to are, on a project, are typically only in the double digits. They're very, very small number of lines that you ever need to do that to. So wait until you know there's a performance problem and you know where it is before going to something like while.
In practice, they are slower, but in practice, it usually doesn't matter. So what Twitter uses Scala, and they have very demanding performance needs. So they said the number 5%. They usually have had to rewrite 5% of their code to make it fast enough.
I'm surprised it's that high, but
that was the highest number I heard. That's why I wanted to give them balance. Okay, last thing. I thought the other thing was last. I apologize. I lied to you, but this really is the last. Believe me. We just wanted to show that you can use it for scripting. Here's how you'd access a file and do something with it. I can import Scala IO source, and then I can, if you pass me a file name, I can say source.fromFile and then the file name .getLines, and then that gives me some kind of sequence of lines. Actually, it's an iterator of lines because it could be massive. And then I can say I can iterate across those lines and print it out with the length of the line preceding the line. Now, console is something that's available in scope, and that's kind of wraps system.out, console.out wraps that, and it's kind of there because Scala is not only on the JVM, it's also on .NET, and it's kind of tries to abstract a little bit away from the virtual machine it's under. So console.out and console.err always work. So when you say print line, you get console.out.println. So to actually print a console.err, I do that. So if you go to the next line, you'll see that's what it prints when you run it on itself. Yeah. So I think that's
okay.
Good.
And yeah, you should do the exercises for Flight 2 at this point.
Yeah, don't do that. That's why I put up that book ad. So we have 95 minutes out of how many? I forgot, 180. That's about half. This might be a good time for a break for questions.
Yeah, so I think what we're going to do, time is really tight, and we want to give you guys as much as we can today. But obviously people need a break as well. Yeah. So what we're going to do is, some of you hopefully have some questions as well at this point.
There's a microphone there. I think we should take like 10 minutes.
Yeah, 10 minutes.
So we're going to start again in 10 minutes.
And questions.
But in the meantime, we'll stand up here and you can ask questions over there. Line up behind this. I think the mic is right here
yes,
next to you, sitting there.
And probably one on the other side as well.
I see it. There
Can't
it is.
see one on the other side.
So if somebody has questions, come on up.
Yeah. Or if you just want to run around screaming.
Actually, you can also, I think it's better for...
Just do it quietly.
For the video to ask questions there.
Nobody questions? Comments?
Here comes one. Superman has a question, right? Yes. No,
Yay.
he's leaving.
No,
okay.
No, he's leaving.
He's making a statement instead of having a question. They're talking among themselves.
Okay, that's fine. Yeah, a question.
Hey, how are you doing?
But suppose that you've been working hard and you realize, okay, I need some kind of mutability.
Yep.
Okay, so what is the choice you usually make? A var between mutable sets or a mutable collection or a var?
Oh,
great question. Let's repeat it.
Repeat the question for the people. Yep. So the question is, you've been working on some stuff. You decide that you do need some kind of mutability for whatever reason. What would you normally do? Use a mutable collection or use a var? And my answer would be that typically I'd reach for a var first.
That's funny.
And I would attempt to, first of all, make that var private, and also to make it volatile if I know it's going to be in a threaded situation, because then I've got kind of the maximum protection against threading issues, if that thing. Oh.
See? Because you used a var.
Yeah, it is. It's really weird. But yeah, I think I would reach for a private volatile var, first of all, would be my choice. Bill, what would your answer be?
The opposite.
Oh, okay, fair enough.
Which is funny. Now, it all depends on the situation, but I tend to not like vars, so I'll use a mutable object, but it all depends.
Yeah.
Yeah.
We haven't really talked about it, but for threading purposes, there's a scoping in Scala that doesn't exist in Java, which is called private this. And private this is extremely private. It means that thing can only be accessed from inside of the specific instance that it's defined in. And so typically what I would do is I'd make the var private this, I'd make it volatile, and then I'd try and make sure that whatever I did, it's going to be one of these situations of kind of last in wins. So I need to code accordingly for that. So, okay.
Any other questions? Anybody at the mic? You can just yell it out.
We can't see a damn thing
We'll
from down
repeat
here.
the
It's just like lights coming in our faces. So speak up or don't. Anybody still awake? Yes.
What kind of optimizations does Scala offer in terms of primitive types?
Okay, what kind of optimizations does Scala offer in terms of primitive types? Another very good question. Scala doesn't have primitive types. Everything appears to be very standardized. An int is just part of the object hierarchy or the class hierarchy, just like any of your own things are. Behind the scenes, Scala is very aggressive at using primitives wherever it can. And it's actually getting better and better at this. So one of the, within a method, if you pass an int in and you only use things like plus and multiplier, things that you'd expect to see on a primitive, it will never box that thing. It will use it as a primitive throughout the code. If it needs to box it, it will. And one of the areas where you sometimes need boxing is if you use a function literal. Okay, the function literal can be defined. If the function literal takes an object, it's valid to pass it an int, right? But it's going to box it when you pass it that int because you've defined it in terms of an object. There's an annotation that you have available called @specialized in Scala, and if you use that annotation, it will actually create different versions of the function literal with versions for all of the primitives that you specify. So you can say @specialized for int, double, and float, at which point it will create new anonymous method or a new anonymous functions that work on the primitive versions of those, so it doesn't have to box them. And so it's a coarse tool for performance, but if you really need it, you can use it. You can use @specialized to get, to claw back some of that performance to make it not do the auto boxing and stuff like that. The danger with that is if you have a function literal that takes 3 parameters and they can all be independent, they can all be an int, a boolean, and a double, or whatever combination, you're going to end up with a combinatorial explosion if you just make the whole thing @specialized. So you have to use it with care because it's trading off number of implementations for performance. So it's a sledgehammer to crack a nut, but it can be very useful if you need it. In truth, most of the time you just don't care that much about the performance. It's not in a tight loop, so you probably don't need to @specialize it. You'll see it a lot, though, in the Scala collection libraries where performance really does matter. So
I want to just show this. This is Scala doc. It's like Java doc, except it has one nice feature that I really like, which is this search here. So I can search for int, and I wanted to show you that it is just a class with methods. So all those methods like plus, times, divides, all those things you can normally do in Java are methods in this int class. So what it does is it gives you kind of conceptually one world. You don't have the world of primitive types and reference types like you do in Java. The reason Java had that was for performance, but what Scala does is the compiler just uses the bytecodes for primitive arithmetic whenever it can, by default, and when it needs to box, it boxes. So you end up with the similar performance, but just simpler for the programmer. We have time for 3 more minutes.
There's another question?
Somewhere you use yield to transform an array to another array.
Yes.
Keyword, or is it
That's a great question. So yield, we showed yield inside of a for expression. to create, so when you use yield, it turns the expression into a functional or a potentially functional solution because you're giving something back. Yield is actually a keyword. It is, you cannot call one of your methods, oh, sorry, or you can't call a method or
a val.
Or a val.
I tried to, you get a really good error message too.
Yeah, not so much.
Actually, we understand that, but what you can do, if you need to call like yield method on thread, is put it in backticks.
Yeah.
So when I call thread.yield, I have to say thread.backticks yield because it is a keyword.
Yeah.
Now to use this one, I have to actually use, if I just say yield, it'll think it's a syntax error, but if I say backticks yield, then it'll use it.
There aren't many keywords in Scala, but there are some. If, for, yield, val, var.
Personification? Oh no, that's not a keyword.
There's a bunch of them. There aren't as many keywords as there are in Java. And in fact, you'll find that a lot of things that are keywords in Java are actually annotations in Scala. So for example, volatile is a keyword in Java. It's an @volatile annotation in Scala. Means the same thing, but it's not gone from the pool of things that you can use.
And we have room for one more if
Yep.
time is, what do we have? We have the luxury of time. If there isn't one, we'll go ahead and go, but let's just see. Yes?
Any special profiling tools? I use the same profiling tools for Scala that I use for Java. It's a little weirder, or it's a little different. But you kind of learn the quirks as you go. And it's similar with code coverage tools. You can use code coverage tools from Java. They work pretty well. Occasionally, a line in Scala will say, I'm not fully covered. It'll give you like a branch condition. It'll say, you're not actually testing the other side of this. In fact, the code is safe. You get to learn that. But you'll often see, like in case statements or match statements in Scala, you'll see this line isn't properly covered. It actually is. And you just kind of get to know that. But the tools are thinking that you're doing Java code and you're actually doing Scala code. I think that will improve over time as well. There is already a Scala coverage tool called SCCT that if you can use it, it's better, it's closer. But performance, I think I use Visual VM mostly. That's a pretty good choice. And I've used that to track down performance problems successfully and rewrite bits of code to make it faster. So.
Okay, why don't we burn through these?
Okay.
We may try to get
sure.
on more. But,
okay. So